Yay. You would hope. You would hope I would know how to start a live stream by now. But yes, it still takes some time. Have to check quite a few things. Sorry for my voice is still crackling. I'll try to use the text to speech more often. Just share the link quickly. Bear with me. We're doing I'm doing Twitter and LinkedIn. Hit the description. Don't have the description. Why don't I have the description? Oops. That's not. Oh, come on. Let's see. Select and then jumps straight into it. It's not intentional. Oh, please. Can I just copy this? Without going into it or anything. Right. EEG Data in Python live stream. Okay, I can post that. Sorry for the notifications probably going straight into my stream. Sorry for that. So we have a bunch of tools in here. Some of them work, some of them unfortunately stopped working. So I want to look at something like this EEG review. So this is a specific case so that this tool doesn't work because I mentioned earlier it don't have the backend. This video is still quite popular. So this is where the tool is actually being used. So it's scrolling through EEG there. So let's see. So that data is from IEG.org. We have an account. I think anyone, pretty sure anyone can register. This one actually says 0. That's well, I don't have any datasets that I uploaded, but you can essentially search your datasets. Yeah, you have a lot of different study search, generalize so specific around the epilepsy. So I have non-epileptic EEG, but we do like epilepsy. So with seizures, if it just do search, will it give us any datasets? No, not the greatest user interface there. I don't remember the ID of the dataset I was looking at. Generalized. Let's just click generalized, then search. your search was too narrow. That didn't work. Last try. Let's try. A generalized tonic-clonic partial complex. No, give me anything. Any data set. Temporal. Okay, that doesn't. Oh, actually, sorry for that. We do have data sets there. Right, so we have all these data sets from 6 or 7 items from UCLA. Temporal, and they're in EDF, some sort of EDF file format, which is standard way of storing files. And we can actually, so we have a limbic temporal seizure there, for example. It's 2-minute recording. We have time series. We can display them on the screen. It's not ideal display from memory. Yeah, the whole interface is just have this PDF that doesn't work as well. Find us view docs. Right. So this one, amygdala. It's the number of channels, their locations. So your standard stuff. Right. Oh. Open as a create project, view EEG. Right, long loading time series data. So yes, you can do it directly on the page. But well, first, yeah, loading for quite some time. I would imagine sometimes it would not load at all. Yeah, so I was using the stuff before. I mean, it's just a repository. Yeah, while it's loading, let's check the GitHub page. So at the University of Pennsylvania, looks impressive. I don't know anything about it. That's why it looks impressive. Seemed to be updated 4 years ago, 8 years ago. License, I don't know what the license is. You can check it later. I assume it's a Apache license, which is great. Permissions, private use, any commercial use, yes. So yeah, very permissive license. And we'll need to place a notice. So essentially keep the same license in our project, which we can definitely do, especially if we just fork it. There's already 8 forks. And I forget my... Did it load anything? No, it's still loading. So yeah, you can tell it's a bit of a useless interface there. I'm not sure what's it doing. Is it too large, or is it still loading? Did it stop? Don't know. So we have this Python file. Yeah, we need your dataset ID code, essentially. Yes, this thing goes back to 2019 or something. Let's see. So I don't like, yeah, I'm not fully actually using GitHub. I have some stuff on GitHub. I'm not actually signed in. I don't have to, I would imagine. Actually have that data already, some of this data already downloaded somewhere. Perchance process condition. Just go back one sec. So it's using NumPy pandas. I'm not sure what that is. Some sort of Penn University thing. Just get ChatGPT to help us out. Let's open. I haven't tried this before, really. We open two windows. One we'll have it in 3.5 and that one in 4. So it's good that it's old data. It's been sitting there for quite some time. So I can't read properly. Oop. Wrong button.
Developed in 2015, and it was substantially updated in 2019 to add greater functionality and to make it compatible with modern Python versions.
So we have an active account and password. And let's see what else to do. Let's check out sorry, EEG2. So in this folder, yeah, this is the legacy code that doesn't work anymore. Let me just check if let's intracranial EEG. That's the dataset that we were loading prior. There's, yeah, just remember that there was actually no proper file name for this. Sorry, the project name. It is project ID thing. So that's not the one we want. Experiment search. So actually that experiment is right, that's the one. That's the one we used before. So I'm kinda familiar with this device. And also the reason I like this one is much longer. So it's long-term recordings. Just look at the first file. I think this one was loading as well. View EEG. Right, this one actually doing something. Right, so this is great. It's scrolling. Does look like it's actually. Oop. Right, so mouse scroll. Yeah, so it's a nice interface. I don't know what was it written in. Oop, that's okay. I don't know what it's trying to do. Don't know. It's weird, but trying to see. Yeah. Well, yeah, it is working. It's pretty slow. I mean, this file is very large. It's like 4 or 5 days. Loading quite slowly. Could definitely improve on that. Anyway, back to the GitHub page. Let's start a new Python in this page. Start a new main py. Let's just ask if 3.5.
You can install the Python packages requests, numpy, pandas, deprecation, and penprov using the pip command. Open your terminal or command prompt and run the following command. This command will download and install the specified packages from the Python package index, pip, if they are available.
Okay.
Make sure you have Python and pip. In this example, the deprecation.deprecated decorator is applied to the old underscore function. The deprecation library is a Python package used for handling deprecation warnings and messages in code. It provides a simple way to mark certain functions, classes, or methods as deprecated, which can help developers communicate to users of their code that specific features or functionality will be removed or changed in future versions.
Okay. And this one.
As of my last knowledge update in September 2021, I do not have specific information about a Python package or library named penprov. It's possible that this library was developed or released after my last update, or it may not be widely known or documented.
Right, so this penprov, something specific to the Penn University dataset. We do have a username and password. So we can open dataset, close dataset. Should be able to save the dataset as well. Last time we was saving the dataset into, so originally those are EDF files. Actually close this one. Just open another there's this documentation as well. View doc, internal error. Okay. Yeah, I don't think this one is greatly maintained. Already open. It's already open. And view doc. No, still not working. That's okay. We're mainly after the data. We need the data. Yeah, so it's loading something. It's getting some errors and things. I think it's actually trying to do something with my profile over there. You know, I think eventually it will work. Anyway, long story short, the data is there. That's what's it's important. Yeah, this might be a bit of a problem that GPT, if GPT doesn't know about one of those libraries, we might have trouble using it. How is it being used anyway? Right, so it's just used to connect to that server from within Python. Sorry for that. We lost some people, some traffic before. Sometimes it's not updated the YouTube thing. Read sample. I want to read sample and also store it. Printing a shape. Doing some sort of scaling, is it? No. That's the start time. I was wondering if this was tested with one of the dataset, like what, how to make sure it's actually working with all the datasets. University of Pennsylvania. Read sample. Okay, let's rename this. Just in case. Right. So I do need to install stuff. Notations, data, get data montages, improve example. So I'm not logged in my GitHub, so I'll have to do this manually. Doesn't say anything about IEG setup. Let's go over this functions quickly.
Open underscore dataset, name, fetches the metadata for an EEG dataset by its unique ID. Returns a dataset object. Close underscore dataset, DS, closes the connection for an EEG dataset associated with a dataset object. Time series details, EEG, dataset. You may access any of the following variables: acquisition system if stored for channel. Name, internal name if stored for channel, often chan underscore name. Channel underscore label, IEEG.org channel label and unique ID for channel. Min underscore sample and max underscore sample, minimum and maximum integer value for each channel. Voltage underscore conversion underscore factor, factor to multiply each sample by to get the actual voltage reading. Number underscore of underscore samples, number of samples in the channel recording. Start underscore time, official, start time of the recording in UTC. For human data this is usually masked. End underscore time, official, end time of the recording in UTC. For human data this is usually masked. Sample underscore rate, sample rate of the recording in HC. A float.
Okay, so we're not forking, just downloaded the whole lot. Extracted here. Just start another. Yeah, start a main folder. IG by master. Yeah, I have the license. setup. So after installing those, we can run the read sample by penprof. Right, that's went away. Okay, how do I, is there a way in Python to write things down without the being visible? So that will be a good question for Stripe bot. Yeah, they changed this well. If I can do them. In Visual Studio Code, how do I enter username and password without in Visual Studio Code, how do I enter username and password without the text being visible in a Python script? So that would be just give me something simple.
In Visual Studio Code, VS Code, you can enter a username and password without the text being visible by using the getPass module, which allows you to input sensitive information securely without displaying it on the screen. Here's how you can use it in a Python script. Import the getPass module at the beginning of your script. Use getPass to get the password input from the user. When you run this code, the password input will not be visible as you type it. The getPass function hides the input for security reasons.
Does it actually work? Why do I doubt it? What? Obviously, wasn't that simple. It's only when you run the code. Don't get it. No, it's okay. I just don't want it to run. Right, so that's using in the, okay. Oop. Okay, so does work. We'll just type it in the get rid of that. Read sample. Right, so when we run this, it's asking us for username and password. Check it. Written somewhere, yes. The username. What? Get pass to your username. Why do I see this text? Because I didn't run the code. No, still see the text. What's up? Start again. Right. The username is not the. Can I hide the username as well? It doesn't matter. Okay, username. Password. Okay. What's the problem? Ah, because of the name. To run it again. Okay, if we're already showing the username, might as well pop it in here. comment that out. Stop that. Let's do this again. To your password. Okay, that didn't work. Why that doesn't work? Let me check. Sorry for that. It still doesn't work. Right, this dataset will have to change. My ID. Okay, we have the data downloaded. Let me just work with what are the EDF files. Should be able to do that. So I'm having trouble connecting to the server. It's still working. It's working okay. Three 3.5. Can you write Python script that opens and reads an EDF file? Yeah, that's right. That's EDF, not. So there's an EDF library that we can use that GPT seem to be familiar with. I also popped it in the wrong folder. Sorry for that. Making lots of mistakes. Okay, so that didn't work. Let's just give me a second, find those files. one, one.
And signal descriptions, e.g., labels, physical units, sample rates. It also specifies the format version, which can be EDF or EDF+, an extended version of EDF. DAT records. After the header section, there are one or more DAT records. Each DAT record contains the actual time series signal data. The DAT records follow the format specified in the header. Signals may be sampled at different rates, and DAT records can vary in duration. Signal information. Each signal in the EDF file is identified by a label, e.g., ECG, and may have associated physical units, e.g., microV for microvolts, BPM for beats per minute. The header includes information about the number of samples per DAT record and the physical amplitude range. Sample format. EDF typically stores data as 16-bit integers, although it can support other formats. The actual physical values can be obtained by applying a scale factor specified in the header. Time information. EDF records time in seconds, and the start time is specified in the header. The time information allows for synchronization and alignment of different signals. Annotations. EDF Plus format includes annotations, which can be used to mark events or other annotations related to the data. Compatibility. EDF files are designed to be platform independent and are supported by various software tools and libraries for reading and processing. Extensions. EDF Plus extends the basic EDF format by adding features such as event annotations and additional signal information. Software support. There are libraries and tools available in multiple programming languages, e.g., Python's PyFlib, MATLAB, for reading and working with EDF files. EDF files are crucial for the storage and sharing of biomedical data in a standardized manner, making them accessible to researchers and healthcare professionals for analysis and interpretation. Understanding the structure and content of EDF files is essential when working with physiological and biological data.
I have them as text files, not too big. I don't know why I have them as text file, but there's like a 2 gigabyte text. Pretty sure it was the name matches. That was smaller. Smaller file. No. Let's try this text. So it's not an ADF. Crashing, I just need to open parts of it. Let's use this was GPT 3.5. use GPT-4 here. Yeah, this will be an example. So I have a large text file containing 16 channel EEG data. How do I open say 1,000 samples out of this file in using Python? So no, we don't want to open it.
To open and extract the first 1,000 symbols or characters from a large text file in Python, you can use the built-in open function to read the file and then use string slicing to get the first 1,000 symbols. Here's an example. If your EEG data is in a structured format, like CSV or JSON, it might be better to use a library like pandas to read the data, which will allow you to handle the data more effectively. For instance, if it is in a CSV format, you could do something like: make sure to replace path slash to slash your slash file.txt and path slash to slash your slash file.csv with the actual path to your file. Moreover, it's essential to know what you mean by symbols. If a symbol is not a single character and instead represents a more complex structure in your file, you will need to adjust the reading and slicing logic accordingly.
That's a good start. Okay, let's progress this thing quicker. This file just in the same folder. Print data. Text files. Okay. Right. So we have the data. Assume this would be each channel. Print how many columns the text file has. It's not CSV.
Find out how many columns a CSV file. I assume you're referring to a CSV file by mentioning text file. As using Python, you can use the pandas library. Here's how you can do this. First, ensure you have the pandas library installed in your Python environment. You can install it using the following command. If it's not already installed, bash copy code pip install pandas. Next, use the following script to read the file and print the number of columns. Remember to replace path slash to slash your slash taxfile.csv with the actual path to your tax file. To find out how many columns a .txt file has, you need to read at least one row of the file and then analyze that row to determine the number of columns. Here,
the delimiter is what is the delimiter?
The delimiter in the snippet of your data seems to be a whitespace tab or space. You can use the CSV module with a whitespace delimiter to find out the number of columns. Here's how you can do it.
Should be 16, is it? Why is this number? This number doesn't make sense.
This script tries to read your file as a tab-separated file, as indicated by the T delimiter. If the columns are separated by spaces instead, you might need to use a space as the delimiter. If the number of spaces between columns is inconsistent, you might need to use a regular expression to match one or more spaces as the delimiter. This can be done using the re module and setting the delimiter to re, compile, r, s+, where s+ matches one or more whitespace characters.
They are not spaces, are they? They are tabs. How to find all the delimiters in a text file? Not right. It's the wrong file. Right, that's more like it. Sorry, I made a mistake. treat all columns. A modified Python code to treat all columns as time series data. Plot the first to say 100 points of each in the same window. So it could be overlaid or not, don't care.
To plot the first 100 points of each column as a time series in the same window, you can modify the script to use pandas for data handling and matplotlib for plotting. Here's how you can do it. Explanation. The script uses pandas, read underscore CSV with delm underscore whitespace equals true to read the file treating any whitespace, space or tab as the delimiter.
Let's sec. Let's pop all that in.
To treat all columns as time series data and plot the first 100 points of each column in the same window, you would modify your script to use matplotlib to plot the data. You can also use pandas to handle the data more efficiently. Here's how you could modify your script. First, install pandas and matplotlib by running the following command in your terminal. Then, you can use the following script to read the data and plot the first 100 points of each column in the same window. This script is the following. Imports the necessary libraries, pandas and matplotlib. Reads the data file using a regex delimiter, s+, to match one or more whitespace characters, spaces or tabs. Prints the number of columns. Plots the first 100 points of each column in the same window. Adds a legend to the plot and shows the plot in a window. When you run this script, it should show a window with a plot containing the first 100 points of each column in your data file.
Yeah, that's too many data points. It's still loading something. Right, so we got the data. That took some time to plot. It took some time to plot. Can we improve speed? Also, we would like to add a horizontal scroller to be able to move within the file back and forth.
To improve the speed of plotting, one approach can be to use a more low-level library for plotting like pyplot directly, which tends to be faster. Moreover, adding a horizontal scroll bar would require using a more interactive plotting library, such as Plotly, which supports various interactive features including zooming and panning, which can effectively be used as a scroll bar to move back and forth in the plot. First, install the necessary libraries. Now, let's modify your script to use Plotly for faster and interactive plotting. This script uses Plotly, Express to create an interactive line plot of the first 100 points of each column. The range slider underscore visible equals true setting adds a horizontal scroll bar to the x-axis, allowing you to scroll back and forth in the plot. You can also zoom and pan in the plot using the interactive controls provided by Plotly. The Plotly library should be faster than matplotlib for plotting large datasets, and the use of a pandas data frame should allow for efficient data handling. Remember that the script reads only the first 100 points to plot. If you want to plot more points, you can adjust the slicing of the data frame, df, iloc 100, to include more points. However, applying more points will increase the time it takes to generate the plot.
Only using like bugger all CPU. It's taking forever, well, because it's reading 6 gigabyte in memory. What? Still loading. So how's that faster? Okay, so first okay, it's a nice interface, but took forever to plot. It took forever.
Remember that the script reads only the first 100 points to plot. If you want to plot more points, you can adjust the slicing of the DAV frame, df, iloc 100 to include more points. However, plotting more points will increase the time it takes to generate the plot.
Okay, a couple of things. We would like the number of data points to be a standalone variable that we can change. Also, the loading time is very long. Takes too long to display anything to begin with. What can we do? There's something wrong.
To address your concerns, we can do the following. We can define a standalone variable to specify the number of points to be plotted, which you can change as per your needs. To reduce the initial loading time, we can read only a subset of rows from the file instead of reading the entire file at once. Later, if necessary, we can load more data in chunks. Here's how you can do it.
Right, didn't realize it's loading the whole file.
In this script, we define a num underscore points underscore to underscore plot variable that you can change to specify the number of points to plot. We're using the nrows parameter in the read underscore CSV function to read only a subset of rows from the file, in this case, 1000 rows, to reduce the initial loading time. You can adjust the nrows parameter as necessary to balance between loading time and the number of points you want to plot. To further reduce loading time, you might consider reducing the number of points that you're plotting, or you might look into using more performant data storage formats, like binary formats, that can be read more quickly than text formats, but that would be a more substantial change to your workflow.
Crawler. It doesn't work. Just that. So reading a subset, should it be? Okay, so this is much quicker. And we can do this. Okay, great. Yeah, having always this problem of the thing stretching. Okay, let's. So what if we load 1,000 points? Don't get it. Explain that to me.
We define a num underscore points underscore to underscore plot variable that you can change to specify the number of points to plot. We're using the nrows parameter in the read underscore CSV function to read only a subset of rows from the file, in this case, 1000 rows, to reduce the initial loading time. You can adjust the nrows parameter as necessary to balance between loading time and the number of points you want to plot. To further reduce loading time, you might consider reducing the number of points that you're plotting, or you might look into using more performant data storage formats, like binary formats, that can be read more quickly than text formats, but that would be a more substantial change to your workflow.
There's a thing about so it's a nice little window. That's okay. A question. We're loading 1,000 data points from the file and plotting 100, but the scrolling window seemed to display the whole data when loading the first time. So that wasn't clear, but
to display the whole dataset while starting with a smaller subset for faster loading and interactive exploration, you can consider the following steps. Initially load a smaller chunk of data to display quickly, like 1000 points. Plot this data with a scroll bar to allow scrolling. Implement a mechanism to load additional data as the user scrolls. This would be a bit complex as it would require some callback mechanism to load more data when the user scrolls. Unfortunately, implementing step 3 in a script running outside of a web framework or an application with a GUI backend can be quite complex because it requires a persistent process that can handle callbacks from the plotting library. However, for a simpler approach, we can just load and plot the entire data while indicating a smaller window, e.g., 100 points, for initial display. Here's how you can modify your script to implement this. In this script, we're loading the entire dataset but setting the initial x-axis range to display only the first num underscore points underscore to underscore display underscore initially points. The range slider will allow you to scroll through the entire dataset, and you can also adjust the window size of the range slider to display more or fewer points at a time. This approach will allow a quicker initial display with the ability to explore the entire dataset, but the initial data loading time will still depend on the size of the entire dataset. If the initial loading time is too long, you might need to explore more advanced techniques to load and display your data incrementally.
so this one is loading the whole thing. Let's serve that. So this copy is working. Okay. Let's see how long it takes for this to load. Yeah, okay. Yeah, that's no good. But what I was, well, it's not killed. Should happen.
It appears that your script was terminated before it could complete, possibly due to running out of memory or exceeding some other system resource limit. When working with large data files, it can be helpful to use techniques that reduce the amount of data that needs to be loaded into memory at one time. Here are a few strategies you might consider. Reading data in chunks. You can read the data in chunks and then plot a specific chunk. This way, not all data is loaded into memory at once. Here's how you can modify your script to read and plot data in chunks. Python copy code import pandas as PD. Import plotly, express as px. Hash standalone variable to specify the number of points to display initially. Num underscore points underscore to underscore display underscore initially equals 100. Chunk underscore size equals 1000. Hash create an iterator to read data in chunks. Reader equals PD. Read underscore CSV, /home /ubudme /bionicchaos site /ieg underscore 2 /i004 underscore a0002 underscore d001 underscore day1.txt, delm underscore whites.
Okay, sorry for that. It's normally not reading the actual code. So I didn't realize we've been in this stream for over time. But yeah, this looks really good. You can set the number of points that are loaded. Yeah, we need to treat those fix those edge cases. We also need to automate the fact that once you get to the end here, it will load more data. Also this data, we also need to make sure we're plotting the right thing. But 10,000 can we handle? 10,000. Yeah, we need to make sure. So we have those 16 shells. Anyway, the interface looks great. Hopefully we'll have something like this running on Bionic Chaos soon. So I'll just take a break and see you in a bit.